Great. Thank you, Jason, for getting everyone sort of in the mindset of a scientist. I'm actually an engineer, so I'm thinking not only about science, but also about technology. And another topic that comes up in the news and might sort of explain why it is that our friend is sort of railing against fracking on Facebook is a broad topic, and that's energy. So energy can pop up in the news in a number of different ways. Some of them may be just mundane, day-to-day, like the rise and fall of gas prices. Or maybe something a little bit more serious, like the role of nuclear energy and the decisions to be made about nuclear energy in our society. Or perhaps maybe some older folks will remember in the 70s there was a national crisis in energy due to a shortage of supply, and a lot of folks couldn't even fill their gas tanks on certain days. So what I want to talk about in particular, to sort of frame why it is that fracking is such an important topic of debate, has to do with a recent change in the way that we discuss energy in the United States, and something that sort of changed pretty significantly around 2006 or so, about 10 years ago. So that has to do fundamentally with this graph, which I'll sort of try and walk through pretty broadly. What's happening is, starting from the far left and then sort of marching month by month from 1993 until present day, what this graph is tracking is the US net imports of petroleum. And to sort of break that term down, net imports is referring to imports, so how much is it that the United States is buying from other countries, minus exports, or how much is the US selling to other countries of petroleum. So petroleum encompasses things like oil and gas, fuels that we use for energy and to fill our cars. So if you're in this red region, that means that the amount that we have to buy is greater than the amount we can afford to sell because we're using so much. And that likely means you're relying on these sort of large oil tankers to bring in extra oil from possibly politically volatile regions like the Middle East. If you can get down into this green region, that means we can actually afford to sell more of the energy produced in the United States due to extra supply, which is definitely a benefit because we don't have to rely on other countries. Now, what happened around 2006 was we had been in this red zone for quite a long time. And right about when this value peaked in 2006, something happened. And we sort of started following this steady trajectory to the point where we've sort of achieved, we've entered into this green region. So what is it that happened in 2006? Well, exports exceeded imports of total petroleum products, namely because natural gas, sort of one major component of petroleum, took off. We started producing a ton of it, way more than we had before. And the main reason for that is because we learned how to get natural gas out of this rock called shale. It's this picture here, pretty harmless looking black rock. It's also the background at each one of these slides. And the thing about shale is it's very, very abundant in the United States. So this map overlay, what it's showing those sort of giant blobs. So the light blue blobs, and then to an even greater extent, the dark blue blobs, they represent these natural gas, these shale plays or these formations that are deep underground. And we've known about them for a long time, and we've sort of known where they are from maybe in the Northeast, in Pennsylvania, North Dakota, or places like Texas. However, we weren't able to efficiently get the natural gas out of this shale, enable it sort of to turn a profit, except for a more recent technological innovation that sort of allowed us to get the natural gas out of shale, and that's called high volume hydraulic fracturing. It was a technique developed by scientists, engineers, and oil and gas companies looking to extract this resource. It sort of took off, this technique got really popular, so we gave it a nickname, fracking, which is probably what most folks have heard of it as. So what I want to cover here is, well, what is fracking? How does it work? And maybe more importantly, how is it that we go from sort of this science or technological sort of development, and how does it get so controversial? How does it sort of evolve into these opinions that you may see on Facebook? So the very first thing I want to do, just to make sure everyone's on the same page, is just talk about natural gas very briefly at large. So natural gas, the main component is methane, which is a flammable gas. You might recognize it from your stove. It's what you use to cook your food, or maybe even to heat your house in places like Connecticut. Now, natural gas has a pretty good reputation in the fossil fuel sort of world, that is fuels that we extract from deep underground, because relative to coal, or I'm going to show here charcoal, sort of the household equivalent of coal, it's a heck of a lot cleaner. And I think you can sort of picture that when you think about the fact that if you're going to grill, if you're going to use charcoal, you got to do it outside because of all that smoke and soot that forms, as opposed to that nice clean blue flame that can come off of your stove. Now, it also has this name, sort of from its good reputation, as the transition fuel. And that has to do with its comparison also to maybe sort of our best answer to renewable energy, which is solar, or something like solar, where it doesn't leave any sort of footprint and it's perfectly renewable. Now, it's called transition because let's say natural gas is suddenly abundant like it is in the United States. We can perhaps start to increase the amount of natural gas we use for energy, at the same time start decreasing the amount of coal that we use. And in the meantime, maybe that high price tag that sort of prohibits us from using solar at a large scale will start to go down, and we can transition over to that. So now that we know what natural gas is, before I get quite into what fracking is, I want to just sort of get us into the mindset of what this controversy looks like and what these arguments are that are being thrown back and forth. So the way I see it, there's two extreme camps, and most folks probably actually fall somewhere in between. But I would say on the one extreme side, maybe you have your environmentalists who they're going to paint a sign and go to a protest. They'll say something like, "Don't frack with my future." They don't want to see fracking in their neighborhoods. Meanwhile, the pro-business side, they're quite content to simply point to the economic benefits and just sort of demonstrate that fracking has created jobs. To which the environmentalists might go back out, buy a bigger poster board, paint a bigger sign that says, "Well, we can't drink money. And because of fracking, people like this woman here, their water is flammable," and you can see she's holding a match under her faucet and it's creating a flame. However, the natural gas advocates are pretty confident that it's not their fault. If there's natural gas or anything flammable in that water, it's always been there. So who's right? Well, to get to that, I first want to discuss, well, what is fracking? How does it work? Why is it so special? And to do that, I'm going to use this sort of simple schematic. What this is trying to just show here is starting on the surface. You've got maybe your grass and your soil. Groundwater is typically maybe just a couple hundred feet below the surface. And this isn't to scale. Usually maybe thousands or so feet below that is where you finally get that natural gas rich shale layer. So like most oil or gas wells, the first thing you have to do is just drill deep enough to get to that resource. What makes fracking a little bit more unique is the fact that it's required, or it's sort of taken off because of our new ability to drill horizontally to sort of really efficiently access that whole shale layer across. So the hydraulic part of hydraulic fracturing comes first from this fracking fluid. It's a mixture of pretty much 99% water and sand, plus maybe 1% chemical additives. That's mixed on the surface, and then what happens is millions of gallons of this stuff is pumped deep into this well. And the idea is that if you put enough pressure and enough force behind that fluid, you can actually take that shale deep underground and cause it to fracture or break open into thousands and thousands of microscopic cracks, allowing you to access and sort of get that natural gas to escape. So sort of a fun fact, and to explain why maybe that sand is added to that fracking fluid in the first place. The sand acts is what's called a proppant, and I think a good analogy also has to do with another sort of extraction process that's to do with just mining, sort of maybe an old school mine here. What it's showing is there's these miners in this mine shaft, and these wooden logs are sort of put into that shaft to sort of prop it open and keep it from collapsing. And I like to think of the sand as sort of the same way. It's meant to lodge inside each of those cracks, keep them open while that natural gas is allowed to escape. Now, with all that in place, with your natural gas sort of released, what you can do is sort of let off that pressure and allow everything to come back to the surface, and eventually start producing natural gas, which can mean profits for those involved. So, given this process, why are these environmentalists so upset? How is the environment affected? And there are quite a few reasons, certainly not limited to what I think is maybe one of the more obvious ones to folks that actually live in regions with fracking, and that has to do with activities on the surface. So for context, this is actually the very first oil well, sort of historical. This is the Drake well in Pennsylvania over 150 years ago. And so relatively, this is a modest sort of structure, just a wooden tower with a few guys around it, all wearing fun hats. Compare that now to a more modern fracking well pad. So this is just one of maybe hundreds or thousands in certain regions. And it's a pretty major industrial operation. There's sort of this newly paved parking lots, roads leading in and out, dozens and dozens of trucks, chemicals being mixed. And a lot of people are concerned about that because, as this Wall Street Journal article pointed out, some of these wells are quite literally in folks' backyards. So that sort of close co-location, that proximity between where people live and where industrial activity is occurring can definitely pose a significant public health risk. Sort of just offhandedly, pretty much any industrial activity of this nature will also affect air quality. maybe not so surprisingly, a lot of the air quality from these operations simply has to do with all those trucks that are required to bring in the water and maybe bring the waste and the natural gas back out in regions that don't normally see that much truck traffic. And finally, I wanted to just mention earthquakes because it's something I know a lot of people have heard about. This study in particular is looking at a link between fracking in Ohio and earthquakes, but places like Texas and Oklahoma have been in the news quite a bit because of new sort of seismic activity in regions where fracking is developing. But maybe to zoom in a little bit more on one sort of hot button issue is that flammable water. So why is it that this woman is able to hold a match to her faucet and sort of start a flame? So the first sort of hypothesis was that perhaps when we're creating these fractures deep underground, we're sort of enabling a shortcut, a pathway for natural gas to seep into the groundwater at sort of a large, massive scale. Now that hypothesis has pretty much been disproven, at least on a large scale, like originally thought, but it definitely doesn't mean that there isn't a link. So, given that, maybe these natural gas advocates here have a small point in that perhaps it isn't entirely due to fracking that this water is on fire now. But it certainly could be from maybe a fracture that is created further up the well. It doesn't have to travel from all the way underground. Any sort of crack along the way could allow chemicals or natural gas to escape into the groundwater. Or maybe even a little bit more easily and more simply is just anything on the surface, all these trucks, all these chemicals being mixed. A small accident happens, and these things could also simply spill right into the groundwater that way. And I actually just sort of want to mention, sort of briefly, this is a figure from a study that my own research group conducted, where we gathered water samples from groundwater and a lot of people's, from wells in people's backyards. Those are at the triangles shown on this map. Oh, and I should mention this map specifically is from northeastern Pennsylvania, which saw a lot of fracking development from about 2011 to 2014. And what we looked at was, one, how close is it to all these circles, which represent newly drilled fracking wells? And two, can we detect chemicals that might be related to hydraulic fracturing activity? And the answer was that we did in fact detect certain amounts of chemicals. It was actually certainly well below any sort of critically unhealthy or toxic threshold. But we didn't in fact find that they were linked to being closer to a fracking well. And at the same time, our conclusions also led us to believe that they're actually probably more from these sort of surface accidents rather than any sort of well failure along the way. So given all this potential for risk, all these studies that are sort of linking risk to maybe groundwater and people's health to fracking, why do we do it? And the main reason is because it's demonstrated itself as a very viable economic endeavor, and it's created a ton of jobs. So given all of these sort of resources present across our country, if you then overlay it and look at a map of new jobs created in the same sector, oil and gas employment, from about the time that fracking developed, what these shaded colors represent, specifically the purple colors, that represents growth on the order of tens of thousands of jobs, places like Pennsylvania, North Dakota, and Texas, where fracking is the largest. And I also just need to mention again this sort of first figure I showed you, which just goes to show that with this one sort of sudden and widely used technique of hydraulic fracturing across our country, we were able to take the whole nation from a net importer for decades to the point where now it's a net exporter because we suddenly have this great supply of natural gas. However, before I leave off with that, I have a background in chemistry and chemical engineering, so I actually would be remiss if I didn't mention one other benefit that I find pretty fascinating, and that's trying to get at why is it that methane, or this natural gas, this flame in your stove, is so much cleaner than coal or something that you would maybe have to burn outside. And a lot of it has to do with the chemistry of combustion, or the process of burning, and sort of in the chemical realm. And the way that combustion works is you take a fuel, something like natural gas, and you burn it in the presence of oxygen, which is abundant in the air. And what you get is energy. We might recognize it as the heat from this flame or even the light from this flame, as well as some byproducts. Water, usually steam, in the form of steam, as well as carbon dioxide, which will be very important in the next segment where we discuss greenhouse gases. Now what I'm going to do is I'm going to overlay natural gas on the top and coal on the bottom with their chemical structures. So this is what they look like in their simplest forms. And it might be intimidating, but really the only point I want to make is that natural gas, or methane, on the top here, it's pretty simple. It's simply one carbon surrounded by 4 hydrogens, which is good. Carbon and hydrogen, when they're burned, those are what make a good fuel. And the fact that you have this singular carbon surrounded by 4 hydrogen means that you get relatively less carbon dioxide when you burn methane. Now if we compare that to coal, coal is sort of this messy thing. It's a little hard to represent, which is why it sort of is just a segment shown here in this square. But the way that coal is arranged, you actually have something closer to 1 carbon to every 2 hydrogen. So if you're going to burn the same amounts of methane in coal, you're going to get more carbon dioxide, which can again have implications in the climate change segment that'll be coming up next. And finally, another important point is that some of this other junk that's sort of shown in that coal structure, these different colors, the reds, the blues, and the yellows, things like nitrogen and sulfur, those are sort of contaminants in coal. And to put it the most simply, when you burn things with nitrogen and sulfur in them, you get smog and acid rain as byproducts. And that's actually a big problem that China's facing right now, where they're burning a lot of coal to meet with population growth demands, and their cities have pretty significant air pollution problems as a result. So, given all these facts, all these benefits, all these sort of potential risks to the environment, how is it that we've transformed science into something so controversial? A lot of it has to do with the ways that these different groups approach technologies and issues. Environmentalists practice what I might call the precautionary principle, or sort of in lay terms, better safe than sorry. They look at systems, maybe even well-designed systems that had a very low risk for failure, and they see the potential for catastrophe, like the Deepwater Horizon oil spill, which was an oil rig that had been operating perfectly until suddenly an accident happened, and you had one of the largest disasters to the ecosystem that's been seen in decades. On the other side, this pro-business community, or natural gas advocates, they adopt what I would consider maybe more of a manifest destiny philosophy. So the way that maybe Lewis and Clark looked at the West and thought it's ours for exploring, people in the oil and gas industry look at this abundant resource and they say basically it would be a shame if we didn't take advantage of it, especially if it can bring so much benefit to our economy and even maybe national security. So all this boils down to is that in some of these scientific and technology-based topics, you can have these facts, which might be a certain balance of risks and benefits. But what ultimately happens is that things like opinions, that can come from things like personal values or philosophy, they can change the way that we interpret them. And that's how you get arguments on platforms like Facebook or in the media at large. So maybe given that, what's a good way that we can discuss fracking, especially if we're coming from different places, even though we maybe have the same facts? Well, for one, it's just good to be aware that these camps exist. Some people, even if they have all the information, simply might disagree with you. And it's sort of no point in trying to change their opinions or to go about it that way. Two, this is maybe sort of a minor feature of the way that the media works when telling some stories. And it's something I would maybe call sensationalism. And it's driven by the fact that media and maybe people on Facebook want to tell an exciting story to maybe get attention or likes. And a good example of this is CNN very somewhat seriously having a panel of scientists debate whether black holes could explain the disappearance of that Malaysian airline flight a few years back, which of course is ridiculous. And maybe not to the same extent of ridiculousness, but this woman here, the fact that her sink can catch on fire is certainly a problem for her. But I've seen this photo weaponized by a lot of people trying to maybe pass off the problem depicted here as sort of a widespread issue in every instance. And it's used mostly because it evokes feelings, strong feelings of sort of worry and fear that this might be a problem in your own home. And the final point I might leave off is that sometimes the science is nuanced. If there's risks and benefits, the ways in which they can help or harm might be complicated or even spread out. And maybe a way to depict this is from the study that I explained earlier that came from my own research group. And, to quickly summarize again, we did in fact find that the groundwater at these various sort of triangle sites did in fact have higher levels of certain chemicals based on how close they were to all these different dots representing fracking wells. However, on the one hand, it was not a toxic level, and the second hand, it wasn't due to some sort of widespread problem with fracking. It was probably just due to carelessness on these different fracking sites, leading to maybe chemical spills from trucks on site. However, when we published this data, we were actually criticized by environmentalist groups who thought that maybe we were giving a free pass to oil and gas companies because of sort of the caveats that we added to our claims. But at the same time, companies like Halliburton actually hired consultants to sort of try and rebut this study, simply because they didn't want any chemical contamination being blamed on them. So given that, I think that the fact that our results maybe were attacked by both sides and fell into this sort of gray area might actually represent good science, because it sort of shows that there wasn't bias, that our conclusions were sort of complicated and addressed without any sort of preconceived opinions. So given that, and maybe that I've introduced nuance in science, I'm going to pass sort of baton to Daniel, who's going to talk about a very complicated and nuanced field, and that's climate change.